Problem 13 is a compound interest and simple interest problem. In part A, Bob's investing in a bank that offers simple interest. And we want to find out how long it takes for Bob's money to double. Remember that the simple interest formula is interest is equal to the amount that we invest, principal times rate times time. Now, a couple things about the rate. We are used to, from Algebra 2, using rate as a decimal. In the IB formula sheet, they divide the formula by 100 because they're assuming that you're just putting in R as a percent and not as a decimal. So to find the amount of interest Bob would need to double his money, well, he'd need to make $3,000 in interest so that he'd have $6,000 total. So 3,000 is equal to, he's investing 3,000. We are trying to figure out the rate. No, they give us the rate, 4%. You could either write 0.04 or you can take 4 and divide by 100 like the formula sheet shows you, and we're going to calculate the amount of time. So multiply 3,000 by 0.04 and then divide 3,000 by that number, and you can calculate that the amount of time Bob needs is 25 years. In part B, Charles is investing $3,000, but this time we're going to be calculating compound interest. And again, the formula sheet has you dividing by 100. In Algebra 2, we didn't do the problems that way. We just put the rate in as a decimal. And I think that's probably what most of you are used to. Don't put the rate into the formula as a decimal and then divide by 100. It's one or the other. So we want Charles' money to double. Remember that the formula, I think the formula sheet gives you a way to calculate the interest and then it subtracts the principal at the end. What we want to do is just calculate how long it takes for his money to double. So we're going to say, when's he going to have $6,000? If he invests $3,000, 1 plus the rate he's investing at is 3.5%. That's 0.035 divided by, and here we put divided by the number of times we compound per year. We're compounding half yearly, so that means twice a year, and we raise to the power of n, which is 2. So let me write that, 2 times t. Now, there are a couple ways we can solve this problem. We can solve it using logs, which I'll do in a second, or we can solve it using the just using the calculator. Divide both sides by 3,000. 2 is equal to, and I want to take 0.035 and divide by 2, and then I want to add 1 to that. So I've got 1.0175 to the power of 2t. Right here you can just put this into your calculator. You can say y equals 2, and then in the second equation I've got 1.0175 to the power of, and make sure that you put the exponent in parentheses, 2x. Time is our variable, so instead of a t you'll just have an x. And close the parentheses. I've got an extra one. I'll delete that. And I'm going to see what that graph looks like. So there's my y equals 2, and here comes my exponential function. I want to see where those lines cross. Obviously my window isn't big enough, so let's stretch that x value out. You know, I really don't care about negative time, so I'm going to go ahead and make the initial value of x 0. And I don't know, we'll start with guessing 25. We'll hit graph again. So there's 2, and when is 2 equal to that function? And I need to find out where that intersection is. So I find out second, calculate, where do they intersect? I use the 5 button right there. Don't just use trace and try to guess. I want to find out when they intersect. And I've got first curve, I hit enter. Second curve, I hit enter. And it asks me to hit enter again. And it says after 19.976. I'm going to just round that up to 20 years. So after 20 years. Now, let's see how we would do that problem using logs. Again, logs are not part of the IB Math Studies curriculum, but everybody in the room has had Algebra 2, and it might actually be easier for you to do this problem using logs. I'm going to change the pen color so you can see what I'm doing. Take the log of both sides. So I say, oh, the pen color didn't change. The log, that's okay. The log of 2 is equal to the log of 1.0175 to the power of 2t. Using the laws of logs, I bring that exponent down to the front. So the log of 2 is equal to 2t, I'll put that in parentheses, times the log of 1.0175. And now I divide both sides. So the log of 2 divided by the log of 1.0175 is equal to 2t. I'm going to put my answer, figure out my answer in the calculator, and then to actually find out time, I'm going to divide by 2. So let's see what that looks like. I'm going to, let's clear that out, take the log of 2, close that parentheses, that's super important, divide by the log of 1.0175. I'm going to divide that by 2, and I get the exact same answer that I had before, so about 20 years. If you showed all this work and you wrote down 19, let's see, we're going to write 3 sig fig. So the 3 sig fig, no, we're still going to have to write 20 years. There's not going to be any decimals there. Because if you take the 19.9, you're going to use the 7 to round the 9 up to a 0 and round the 19 up to a 20. So you can do that problem either way.